So now we're going to do another example, and we're going to consider a mass m, which is on a bar of length L, which makes an angle theta with respect to the y-axis. So I'm going to define my axes, x and y. And this pivot point is going to be on a shaft at length h, and h is going to be oscillating, given by h naught, and do I use sine or cosine for that? I use, what do I use? Cos. Not that it matters, I could use sine, I could use cosine, but I'll be consistent with what I have in the notes. So h naught cos omega t. And so this shaft, the length oscillates according to this equation, and then we have this pendulum. So this is a free pivot point, mass on length L. And now we're going to analyze this system. So the first thing to do, we write down again our x and y coordinates of this mass. So x is fairly straightforward, just given by L sine theta. Had to stop and think about that for a moment. And y is given by h plus L cosine theta, which is our h naught cos omega t plus L cos theta. So to proceed, we now need to form x dot and y dot. And so for x dot, we have L cos theta, theta dot. And y dot, we now have minus omega h naught sine omega t minus L sine theta, theta dot. So x dot squared is straightforward, but y dot squared takes a little more to work out, so let's do that. Y dot squared, omega squared, h naught squared, sine squared omega t, and there's an L squared, sine squared, theta dot squared, and then there's the cross term, but I have a minus and a minus, so it will be plus 2 omega h naught L sine omega t sine theta, theta dot. So let's just take a moment to double check that before I proceed. And yes, it looks like I have everything correct so far. So the kinetic energy in the system, I have a 1/2 m, and I'm going to have an L squared cos squared theta dot squared. There's an L squared sine squared theta dot squared. And so there'll be an L squared theta dot squared. But then there's the other terms that now involve omega squared h naught squared sine squared omega t. So I've taken care of that, and then plus 2 omega h naught L sine omega t sine theta theta dot. So that is my kinetic energy, and the potential is just given by that height. So I'm going to take the 0 line to be at the base. So the potential is just mg times y, which is an h naught cos omega t plus L cos theta. So we will bring everything together to get kind of a complicated expression, t minus u, but I want to write it down to make sure that I get all the signs correct. One step at a time. 1/2 m L squared theta dot squared t plus 2 omega h naught L and now it's minus u, so minus mg h naught cos omega t plus L cos theta. Okay, so a rather complicated looking Lagrangian, straightforward enough, but just many terms to keep track of. And now we can proceed to derive the Lagrange equation of motion.